Hello, everyone, and welcome to GENLive, the monthly show from genetic engineering and biotechnology news. We're delighted to have you along. This is the show where we invite experts in a key area of biotechnology to discuss the science, technology, and ramifications of their particular specialty. I'm Kevin Davis, editor-at-large with Gen and the author of, because it's relevant for today's discussion, Editing Humanity, the Crispr Revolution and the New Era of Genome Editing. I'm joined by my three comrades in arms, Alex, John, and Juliana. Hello to the gang of four.
Hello. Guys.
Kevin.
Great to have you along. Today, we're discussing the state of ag biotech with three very special guests. Wendy Cernich is the seed business platform R&D leader at Corteva, a big ag company formed by the merger a few years ago of Dow and DuPont. Chloe Paverley is the global regulatory director at Calyx, a publicly traded gene editing biotech company in Minnesota. And Jack Wang is assistant professor in the Department of Forestry and Natural Resources at North Carolina State University and a co-founder of TreeCo, the North Carolina tree company, which is emerging from stealth mode this year. Wendy, Chloe, and Jack, a warm welcome to you, all of you.
Thank you.
Good to be here.
Great to have you.
Despite the immense promise of CRISPR as a gene editing tool in medicine, many experts believe the most important application of this Nobel Prize-winning technology actually lies in agricultural biotechnology. Humanity is facing a global crisis in food production as our crops and plants more broadly are threatened by all kinds of infectious diseases, parasites, droughts, and climate change. CRISPR and other gene editing technologies are widely viewed as essential solutions to this dire situation. With the help of Chloe, Wendy, and Jack, we'll discuss the impact of these new technologies for safeguarding the world's food supply, the current state of GMO regulations, and new applications of plant genome editing. John?
Okay, well, let me start, Wendy. Let's begin with you. Thank you for joining us. So tell us about Corteva. How was the company created, and in a small nutshell, what's the scope of its business?
So I think, as Kevin kind of mentioned at the beginning, we're a relatively new, I guess we're a startup with long history. So we're actually only about 2 years old, just celebrated our second birthday. So we're walking now, back in June. And this company was really formed by the merger of Dow and DuPont. And then we were in sort of a holding pattern for a few years as the merger was assessed by regulators. And then the ultimate plan and strategy from the beginning was to spin out three separate businesses from Dow and DuPont. And Corteva essentially is the ag part of DuPont, which had DuPont crop protection and Pioneer seed. And then Dow AgroSciences, which was the agricultural division of Dow that also had a seeds business, biotech traits, as well as crop protection. So all of those assets coming together with a pure play focus on ag. And I think what really distinguishes what I love about this company is really this long look. And the purpose statement of our company is to enrich the lives of those who produce and those who consume for generations to come. So it's not just about today, it's really a long look approach to how we face some of the challenges that Alex teed up at the beginning, climate change, population growth, and just constraints on land and productivity, and how we can use technology and looking long-term towards technology to solve some of those macro challenges.
Yeah, well, I started covering biotech in the 80s, and I got to tell you, Dow and DuPont, you have a real great lineage there. They were major players then, so you're certainly starting a little bit ahead of the starting gun. So, but what's your role at Corteva?
So I'm actually two months on this new role, this new job. As the merger came, my history is back coming from the Pioneer company working in seed. But then when the merger took place, I had kind of swung to work in crop protection for the last several years. And so back into the seeds area for the last 2 months, and the role really within the R&D leadership team is to work closely with our business platforms, our seed business platform in particular, to develop and align the strategy, the choices that we make, the investment choices, and then really the execution of delivering our pipeline of germplasm, new varieties and hybrids and our brands, as well as a biotech pipeline, and really looking at the technology we'll be talking about today and how that has a fit in our organization for a longer term view.
Yeah, well, before I ask about CRISPR, I don't need to tell you that in terms of medicine, it is the sort of one of the hot topics here. The book on Doudna, Kevin has written a book. There was a clinical trial, I think about a week or two ago, Alex wrote about. First time a human clinical trial showed some efficacy with CRISPR. So in the plant business, how important is CRISPR and gene editing for the future?
We personally believe it's transformational, and for many different reasons. But you know, it's you're able to actually make changes that are found within the crop genome in nature, but do it in a more strategic type of way to get the outcome that you're looking for. And so this has really broad applications for solving many challenges in agriculture. Again, diseases are evolving, so are insects coming and going. They're developing resistance against technology that we have. Also, as we look towards climate change, we know, as we've already started to see, areas are drier in some places, and water is more important. So looking at technology, how can we be more efficient with nitrogen, with water, and overall just looking at how can we accelerate the pace of genetic gain or improvement for crops across the board, using a new technology that kind of puts together the knowledge of the genomes that we have together with a way to, you know, to really help evolve that genome in a way that resembles nature, but is a faster way to do that.
Yeah, I think among all those applications, especially the climate change, we were talking about that before, just looking what's going around in this country, in Europe and South Africa and every place, I think that's going to be a major issue. So I'm glad for that. Juliana, are you going to ask some questions? Chloe?
Yeah, thanks, John. And yeah, Chloe, before I ask you about Calyx, I just want to remind our audience that we'll have time at the end to take your questions. So if you have any questions for our panelists, please put them in the Q&A section of the Zoom. So Chloe, thanks for joining us. And so your company, Calyx, which was spun out of the University of Minnesota by Dan Voitas, has been in the plant gene editing field longer than most. Can you tell us a little bit about Calyx?
Sure. Yeah, it's been a very exciting adventure. So as you mentioned, our company was created about 10 years ago out of the University of Minnesota when Professor Dan Voitas discovered and patented the Talon technology, which is one of the core technologies that we use. So today we're a plant-based biotechnology platform company, really focused on delivering innovations that can revolutionize how the world uses plants. And for this, we use our advanced plant biotechnology platform to develop sustainable products and technologies that can that we could then offer to our customers and partners. So our mission is really to deliver those disruptive plant-based innovations, and those have applicability across a broad range of industries, going from food, pharma, energy, cosmetics, and agriculture, obviously, and more. And the way, I think the uniqueness that we bring is we're really pioneering work because we have that very strong foundational research and unique understanding of plant metabolisms that we've been able to build over the course of a decade.
Great, thanks. And just focusing on Talons for a second, how does the Talon gene editing technology compare to CRISPR? And why is it more beneficial to use it in plants? Is there a reason specifically why Talons would be the method of choice?
So Talon and Crispr are, I'd say, somewhat similar from just what they're able to achieve. The reason we use Talon is obviously because we have a proprietary position with that technology. And also we built over the past decade, we've built that know-how. So in our hands, Talon is a very accurate and precise tool. And we're actually now even advancing to develop a new tool, which we're calling AutoTal, which really uses the value and impact of artificial intelligence and machine learning technologies to help improve the accuracy, the precision, and the use of those talons. So this has the potential to really improve the productivity of editing and reduce or even eliminate potential for off targets by using these predictive analytics.
Oh, great. Okay. That sounds really interesting. I hope we have time to go back to, what was it? Autotal?
AutoTal, yeah.
Autotal. Okay, cool. So hopefully we'll have time at the end to explore that a little bit more. But so right now I'm wondering, what products does Calyx have on the market currently and in the pipeline?
So Calyx was the first company to launch a gene-edited food product in the US, and that was our high oleic soybean product. We launched that in 2019, and this product is obviously high in oleic acid, as its name indicates, which means with those higher levels of monounsaturated fats, we're able to have a qualified health claim for heart healthy. And it also has improved frying stability and shelf life. The next product, kind of next generation of this product that we have in our pipeline is a high oleic, low linolenic product. So really there it's improving its performance for food processors. So it's the next generation, which has enhanced frying ability as well as that nutritional profile and added flexibility now for blending. We have several other products in our pipeline. In particular, one that I'd like to bring attention to is hemp. We're doing pretty exciting work in the hemp space, where hemp has really the potential to offer protein products such as proteins or nutraceuticals, fiber, or even some advanced materials, for example, for construction, insulins, etc. And however, the hemp species today is really like corn was 100 years ago, where it's basically an undomesticated crop with open pollinated varieties only, uncharacterized heterosis and limited pedigree information. So what we've been doing is really, first thing that we did actually is in April, we announced that we were able to successfully transform the hemp genome. And just early this month, we announced that we were developing a seedless hemp, which is basically a triploid hemp. And so that really enables a step change in the innovation approaches for this species and has many solutions that it can bring that would address several of the climate change challenges that we're facing.
Okay, terrific. Well, hopefully we'll have a chance to come back to all of that because it sounds very interesting. And in addition to your regulatory role, but right now I'll pass it over to Kevin.
Thanks, Juliana. Jack, let's bring Jack Wang into the conversation. Hi, Jack. You're assistant professor at North Carolina State University. How did you get interested in plant genetics and agricultural biotechnology?
Well, it started at an early age. So my father was also a forest biotechnologist and forest genetics. So since a very young age, I sort of hung around his lab, learning about all the cool sciences that he was doing. And then when he did a visiting position in Ron Sederov's lab, which as Winnie knows, is the father of tree genetics, the first scientist ever to start in this field. I was just fascinated at a young age about forestry and forest health and forest genetics, as well as a passion for woodwork. So when I get a chance to start a career in this field, I couldn't be more ecstatic, following my passion. And then I got to meet Rhoda Berengu,
Yes.
the pioneer in CRISPR, one of the pioneers in CRISPR technologies, and it just took off from there. So it's been a very exciting journey for sure.
Yeah, well, that's a great segue into our next question. So Rodolphe, for folks who don't know, is a friend of ours because he's the editor-in-chief of the Crispr Journal, which is a sister journal to Genetic Engineering and Biotechnology News, and your colleagues, faculty colleagues at North Carolina State. And so I guess together with Rodolphe, you've decided to, some of his entrepreneurial flair has obviously rubbed off on you because you've recently launched a startup called Trico. Great name. Tell us what the name stands for and what your plans are for this company.
Great, great. Well, Trico actually started off as just a placeholder until we figure out what to name the actual company, and over time it sort of grew on us, and so we decided just go for it. I mean, it's a name that's very, very easy to understand. They couldn't mistake it for any other company. So yeah, I mean, entrepreneurship is very new for me as academia, as a scientist, but also for our field in general. So the Forest Biotech Group, founded by Ron and Vincent Chen, who is the godfather of lignin biosynthesis for our group. Over the past 30-odd years, we've really focused and dedicated ourselves to fundamental basic research, having generated a lot of basic knowledge about tree genetics, how it works, the mechanistic insights, as well as the production of over 10,000 transgenic trees, including and in addition to the hundreds of CRISPR trees that we've produced in recent years. But none of those have been used in a commercial setting or used to benefit society. So when I got a chance to meet Rodolphe, I've always been a major fan of his research, his work. When I got a chance to meet him just over 2 years ago, within half an hour of our first ever discussion, the idea for Trico came about, where it really is timely, relevant, and couldn't be more critical ever to bring the technologies that has been generated, combine that with his genetic insights and CRISPR technologies and tools to really benefit the society for environmental health, for natural resource sustainability, and to address the critical issues that we face today. So
I heard that Trico could be considered short for the North Carolina Tree Company because you are the wood basket of the country, if not the world, correct?
Oh, indeed. So we greatly located right in the heart of the wood basket of the world, that is the southeast of the United States, where we the forest here produce about 17% of all the wood supply used across the globe. So forestry is a major sector in North Carolina. It constitutes over $32 billion to the local economy, as well as being the #1 employer of all the manufacturing sectors. So forestry is for sure very, very important to North Carolina as well as domestically.
Well, we'll come back to food in just a second, but before we do, why do we need CRISPR trees? What are your sort of what's the low-hanging fruit, as it were, in terms of what you're trying to do now, and where can your technology apply to trees? Where could that go in the years and decades ahead?
Sure. So CRISPR, to me, the emergence of CRISPR has been tremendously exciting, and particularly in forestry, where the field is traditionally being very, very slow in development. It's hampered by tremendous biological and societal issues, where if you can imagine forestry, the trees grew on land for decades at a time. So the classical conventional breeding thereof is very, very tedious. So it takes about 10 to 15 years per breeding cycle for a tree. So if you think about the life cycle of trees, breeding is several generations. That's a complete career for any scientist. So when the forests are challenged by invasive pests and pathogens that are decimating our natural tree stands at a rate much faster than breeders can keep up using conventional technologies. That's when novel, innovative tools and methods such as CRISPR comes in, where it has the potential to significantly accelerate tree breeding to minimize or prevent these natural disasters from occurring, and also with the challenge of the growing world population, the constant need for more sustainable biomaterials that can be produced in a way that is consistent with our pursuit of carbon neutrality and such. Really, new technologies beyond the current state of the art are critical, and that's where CRISPR comes in.
Great, thanks, Jack. Alex, over to you.
Thanks, Kevin. And just a reminder that we welcome your questions if you're watching and listening in by writing them in the Q&A section of your Zoom. And we do have one audience question from a viewer named Chris, who asks, directed to Wendy, would you have any contact info in the North Carolina Research Triangle Park area that would take an interest in a small startup seeking support for proof of concept testing for a novel approach to development of plant species-specific eco-friendly herbicides, based on the target plant's genome? And I guess the startup in question is initially targeting hard to control invasive species. The initial target is kudzu, or as Chris calls it, the plant that ate the South.
I think Jack and I are intimately familiar with that plant, both having some roots in North Carolina. Chris, why don't we follow up on that afterwards and maybe loop in Jack too? I'm alumni of NC State, but I'm currently located in Indianapolis. So my network is probably not as robust as Jack, but I'm really interested to hear more about the concept that you're thinking about there. So just find me on LinkedIn and let's connect.
And Wendy, Jack, and Chloe, the next few minutes, I was hoping all three of you could chime in on some questions I had on food and feeding the planet. We hear all the time about climate change, which is a major factor in the challenge of feeding the growing world population. Can you put this issue in perspective for us? How big of a problem are we facing, and how much does that drive the mission at your respective companies?
Well, I can maybe take a shot at that, Alex. You know, I think when you look at macro trends that are going to affect the globe over the next 20 to 30 years, two really rise to the top, and that's climate change and population growth, and the fact that they're both probably going to occur on top of each other. In trying to solve both of those through agriculture, you know, one major global challenge is kind of enough for once, but trying to solve both of those two. So kind of the things that we can see are probably going to happen as populations grow is it's going to put more constraints on production. And at the same time, as prosperity grows during the same time, the diet quality that will be needed in terms of healthy and rich diets is also going to be growing. And so increased demand for protein, whether it's traditional animal produced protein or plant-based protein, is going to become really important to not only meet caloric needs, but meet the quality requirements as you know, as a population is growing. And at the same time, land will be constrained. And so, you know, key things that we can really impact are being more productive with the land that we have, and also bringing higher quality diets from that land. And so, you know, a couple big drivers, I think, probably are protein. Also, we talked a little bit about oil. Chloe was talking about that. Very important to have healthy oils and sustainably produced oils, as well as just general improvement of productivity on the land that is arable to meet the growing needs. The challenge, though, is that where the land is arable in the future may look a little bit different than it does now as climate change. So being ahead of that, really keeping in touch with you know, the latest data on where we see you know, that production is going to be occurring, and making sure that we're keeping those geographies in our line of sight as we're developing products.
Jack or Chloe?
Sure. I think if we're talking about climate change, then we can't really veer too far from forestry. being the largest and most abundant biomass on the terrestrial biosphere, as well as the replacement of petroleum-based products. So those two aspects are, to me, a major focus in the key areas that science and innovation should focus on in the coming years. So in terms of climate change, forests sequester 57% of all the carbon or the biogenic carbon on Earth. So the ability to enhance the sequestration of those carbon and minimize or reduce the amount of carbon dioxide that is released into the atmosphere through the sustainable production of forest variants or enhanced genotypes will have just tremendous everlasting effects on climate change mitigation. So I think from that perspective, CRISPR technologies in particular is very, very important. Now, also in terms of climate change, we have to really address the critical issue that is invasive pests and pathogens. So in the past several decades, over 400 invasive pests and pathogens, the introduction of those have caused havoc to keystone forestry species. One notable example is that of the American chestnut, where the introduction of a chestnut blight about 100 years ago have wiped out the entire species of a keystone foundational forest in the Appalachians, where 1 out of 4 trees used to be American chestnut. So when this disease took over, the Appalachian Mountains, beautiful lush greenery, was almost appeared as a dead forest of gray and dead wood. So technology is the work of my colleague and friends, Bill Power, for example, using biotechnology has developed a method by simply introducing of the oxidase gene that can neutralize the toxin and bring a potential route to the extinction of this critical species. And this is not just a one-off case. We're seeing very similar trends in terms of with hemlocks, for example. So one project that I'm working on is the trying to rescue the hemlocks from going extinct, whereas again it's being attacked by a delicate invasive insect that was introduced in the 50s that has now infected over 90% of the geographical range of hemlocks. So if nothing is done, if no innovation is brought in, hemlocks are likely go extinct again. So these are all issues that we have to really face on and target. Now, in terms of bioenergy and bioproducts, just the sheer volume of carbon that's sequestered in forests, 315 gigatons of it. It provides the most promising resource to replace petroleum-based fuels, energies, and materials as a way of making these more sustainably in a renewable manner. So these are all innovations and approaches that we, as well as our colleagues in the field, are targeting using CRISPR and other novel approaches.
And I'd say, yeah, in addition to what Wendy and Jack covered really well, what we're seeing even in supermarkets is consumer trends really evolving to now consumers wanting to kind of have their vote also for participating in climate change, limiting climate change, and making the choices with certain products that they feel have, in addition to the health benefits, are more sustainable. Obviously, there's a very strong drive for plant-based products, including plant-based proteins. But there's also just in terms of more sustainable products, and actually one of the products that we have in our pipeline is a high saturated fat soybean for palm alternative. So as you know, right, palm oil is an ingredient with significant sustainability and supply chain reliability challenges. And so what we've developed is a palm alternative using US grown soybeans. Essentially what we've been able to do with gene editing is optimize the saturated to unsaturated fat ratio to develop that product that now will be kind of a local grown product with that benefit.
I think that ties into my next question for all three. can you offer some examples of crops that are in jeopardy if we don't use tools like gene editing to engineer new strains that are disease or drought resistant? You mentioned soybeans, for example.
And I don't know that there's so much in jeopardy. I think what we're seeing, though, is the bar is being raised as sustainability and also, Chloe, to your point, consumer preferences coming in. And so I think paying attention to those markets, both in the crops that we are working on currently that are our major global crops, but also looking at this technology is potentially enabling genetic improvement in crops that we're not really working on. Jack, I think it's great what you're working on with trees. Breeding in so many crops is a very tree type species, very long cycle time, very long. And so thinking about how this technology can enable that. So it's not so much that I think the crops are under threat, it's just a need for them to continue to evolve to meet both the yield, the nutritional requirements, and sustainability and the customer preference, the consumer preferences.
Yeah, so even like a crop like hemp, as I was mentioning earlier, it's not so much in jeopardy. I agree kind of with Wendy. It's more that it has a huge potential that is gone mainly untapped for now. And with these gene editing technologies, now what we're able to do is really kind of unleash the crop's whole potential, and then bring it to consumers and just sustainable products to market.
Great. And speaking of sorry, Jack.
So I think in stark contrast to what Wendy and Chloe described for crops in general, in forestry, there are species and trees, entire forests that are in jeopardy due to the effects of climate change and the invasive pests and pathogens, drought, and all the related associated effects. So, in addition to the famous American chestnut and hemlock stories that I just described, and if we refer to the 2019 National Academy of Science report on forest health and biotechnology, you'll see that the USDA has conducted very, very extensive surveys of plant health and forest health and diseases, and noted that in the next 10 or so years, 33 million hectares of forest in the US alone, 25% of which are at risk of losing all of its tree plantations due to the effects of climate change. So there's never been a more pressing need for technologies and innovations to address these issues if we want to continue to preserve the health and sustainability of our environment.
And speaking of food, you mentioned trees. Is there a relationship between, does the challenge to trees and chestnuts, will that spill over into food challenges over time? Is there a relationship there?
Oh, absolutely. I mean, when you talk about the ecosystem, it's very well interconnected. So chestnuts used to provide a tremendous value in terms of the nut itself, feeding the natural and wild animals, birds, and such, as well as the local indigenous population as a source of income. And when the trees went away, they were replaced largely by the oaks and pines that do not produce the edible nut. And so we see a major change in the ecosystem of the Appalachian forest, where there's much less diversity in terms of the number of species, the type of species that occupy those forests. And of course, the social aspects of the Appalachian forest also has changed from what used to be a very rich in cultural aspects now to something that more resembles other forests.
Some news last week about efforts to engineer bananas. Is it too soon to start thinking about someday munching on a CRISPRed banana? Or is that just bananas?
Well, I think Wendy and Chloe can probably attest more to the food, but I mean, genetic engineering in plants or in trees is not new. I mean, we all know that the famous papaya ring virus story, where the papayas almost went extinct, but biotechnology was able to rescue it, so allowing us to still have papayas today. And of course, similar stories can be known from other plant species as well. So, when there are pressing issues that cannot be addressed with conventional methods, we need innovation science. And I think that CRISPR is the most advanced variant of which we have access to.
And I think it is broadly applicable to really, well, any living organisms. You started the call talking about, human therapeutics, and that's sort of the beauty about it. So, looking at this as a way to enable plants to defend themselves against diseases that are coming, that concept applies across all crops, and also as diseases evolve, trying to stay one step ahead of them with this technology.
And then you've probably heard of the GABA tomato that's being developed in Japan, right? So it's kind of back on to the banana question. So that's a product that's been developed through the use of gene editing through the university with, I think, some government subsidies. And that's a product that is now offered to consumers. And because it has those higher levels of GABA amino acid, it's really to lower blood pressure. So it's offering some benefits for consumers again. So everything's possible. It's just a question of kind of identifying that need and then developing it.
Great. John, over to you on GENLive.
Sure. So Chloe, ever since the similar meeting in California in February 1975, regulatory oversight has been a huge part of the evolution of biotech, along with the scientific and business components. And 2 years ago, the European Court of Justice issued I guess many would call a controversial ruling, essentially saying that gene-edited plants would be regulated as GM foods. What was the impact of that ruling, and have there been any development since?
Yeah, so that's very true, John. That was actually a pretty bad day, I think, when I heard those news. The European Court of Justice basically decided that all new mutagenesis was essentially considered GMO. So that really put a huge stall on innovation for the EU, and I'd say, had obviously repercussions in today's world, which is globally traded, had repercussions overseas. I'm optimistic that things are starting to make some good positive progress in the EU. So the EU Commission and Parliament have actually been carrying out some consultations to really try and evaluate what is the impact of the regulations that they might put in place should they decide that gene editing basically has to go through the same process as GMOs, or should they maybe have a more pragmatic, science-based and risk proportionate approach, which would be more similar to what we've been seeing in the US and other like-minded countries, such as Latin America or even Japan, as I was saying, because they're in the process of launching their first gene-edited tomato there.
Yeah. So how does the situation contrast? You just sort of hinted at that a bit with the regulatory situation here in the US and elsewhere.
So in the US, I'd say we have a fairly straightforward path to market where we know what the requirements are. The developers will develop and characterize their product and consult. It's actually a voluntary consultation process in the US where you can consult USDA and NFDA, which is what Calyx did when we brought to market our high-late soybean product. But you know what the requirements are, and it's almost, I'd say, part of what every company is doing as part of their due diligence when they develop and characterize a product to make sure it's safe and you can bring it to market. There are, I'd say, a few like-minded countries. Argentina has definitely taken that approach. I say an even more pragmatic approach, where if your product contains no foreign DNA and could be obtained through conventional breeding, it's not a regulated article. And that's also the approach from USDA. And then in Japan, that's a voluntary it's actually, I think, a mandatory consultation. So countries kind of have varying levels of requirements, but mostly what we're seeing is regulators and countries at large kind of recognizing the value that gene editing can offer and the huge potential that it has for bringing these solutions that we drastically need for addressing climate change and just consumer needs. And so trying to take that more pragmatic and risk proportionate approach for gene edited products.
Yeah, no, it's interesting because for the 40 years I've covered biotech, GMOs have been sort of everywhere, and fear, and just go to any store and milk, vegetables, no GMOs, GMOs. But what's interesting is regarding CRISPR and Talon. So is it your position that gene editing tools like CRISPR and Talons leave no footprint in the genome of the edited plant, and this pose no threat to consumers? There's no GMO.
So it's really important. Gene editing is different. And it's really important to put gene editing back in the context of plant breeding. So what we're able to do with gene editing is essentially do what breeders have been doing for decades, but in a much faster and precise manner, where we're able to delete a few base pairs, which is a process that can and does happen in nature through various environmental stresses, such as solar radiation or other environmental stresses. And what we're able to do is just do it much faster using our gene editing technologies. So we like to think of gene editing as an advanced plant selection process, where the product that we bring to market, at least in the way that we're using it at Calyx and in the way that I think most developers are using CRISPR and Talon, is to develop a product that contains no foreign DNA and could have been obtained through conventional breeding. And that's a key characteristic of these products.
Indeed, it's key, and I just want to follow up. So when you're out talking about your products or consumer groups talk to you, I assume that's right at the top of the list. Or is it too early? Well, no, it isn't too early because you're using these technologies, that this is really a different technology that's being applied.
Yes, absolutely. It's a different technology, but we also are very committed to transparency. So the conversations that we have with consumers are very transparent in terms of how we develop the product, but also of what the product end product is, which is something that could have been obtained through conventional breeding.
Yeah, and maybe just to make a really kind of real example of what Chloe is talking about, you know, we have, let's just take corn. It's a crop that we're very fond of at Corteva, and you know, it's very wide in its germplasm range. So there's genes that are tropical and they contain you know, desirable characteristics, but the normal process through breeding that we would try to introgress those characteristics from tropical germplasm can take many, many, many years. And it's through crossing, as we normally do. The benefit of CRISPR is you can essentially almost take that beneficial trait from the tropical and put it in one cycle into the temperate, and look at the amount of time you save and just the ability that opens up. And I think, Chloe, you made a great point on transparency, because you know, consumers and the industry is really wondering what is in these products, what is the difference between the technologies. And one of the things we've done really to you know, kind of be very transparent with this technology is actually put out a website that will list for every product that we sell the technologies that are, if it's a biotech product, it's going to say which traits are in it. If it doesn't have biotech traits, and gene editing the same way as we look at that technology for our future, but being really honest about what the technology is and the potential of this for just advancing breeding.
Yeah, that's a great idea, because back in the 80s, there was no internet. So to actually put that out there for the public to see, and anybody else is interested, I think that's a great idea. Kevin, going to turn to you.
Thanks, Sean. I want to follow right on Wendy, your point there. I mean, we know that consumers have many health concerns. We see it in the vaccine issue right now, but particularly around genetically modified foods. go to the supermarket, you see more and more non-GMO labels spreading up, even on items that by definition cannot be genetically modified, like water and salt and things like this. So this is a sad development. So you've got a real, it seems to us, I think, a very uphill challenge to win over consumers and explain the nuances of gene editing versus genetically modified food, even if you take this position that, well, okay, we understand why you have those concerns, but this is totally different. I mean, it's got to be more than just putting up a website, right? What are some of the other strategies that you're trying?
No, as we started working with this technology, this is, I guess, even back to the DuPont days before plants. We were working on this with yogurt fermentation and things like that. But, we realized exactly that uphill climb that we had. And so, some of the ways that we've actually engaged is direct interaction. We've hosted insight series, which are really sessions to listen, not to preach. And I think it's important to listen to those perspectives. What are the questions? CRISPR-Con, again, a great forum to have discussions about the technology, like what we're doing today.
Yep.
And then, industry efforts where we've partnered with other companies to be, putting out responsible use guidelines. It's a voluntary mechanism to say, here's how we are going to self-govern and hold ourselves accountable as an industry on how we use this technology. As Chloe said, largely how we think of this technology right now is within the context of the genome of the crop that we're working in, not bringing in foreign DNA. And then, exactly like these kinds of conversations, just to get to the subtleties, because I think if you don't really spend the time to read or think about it, you can group it all together. And these technologies are really totally different. This is not GM.
I just want to jump in and agree with that. I think the real issue for you, because we all know we do this for a business, the difference, once the public hears gene editing, that to a lot of people is going to be a yellow flag. And I think that's, you're the experts, but just doing this for so long. And if you can get that clear to them, I think.
And there's a lot of things. I think these are called NGTs in Europe, advanced breeding, it has a lot of names. And I think, it is important, the words and the audiences that we talk about with this technology, but even more important is to understand what the technology and to think about the implications if we are not allowed to use this technology, then those challenges that we've been talking about at the beginning become really ominous. And I think that's actually what Europe is taking a look at, like, how are we going to meet our sustainability goals and to address the environment that we're in by locking ourselves out of technology.
I'm sure Germany is asking that question right now with what they've been going through in climate change. Kevin?
Yep. Chloe, did you want to get a quick word in on that point before we move on?
Yeah, I just think, just kind of going back to the consumer acceptability, what we're seeing today is also consumer trends that are really growing towards product that meet their values for addressing their health and sustainability needs. And I think that's all the more true for the younger consumers that are more willing to accept or eat tech-assisted foods if they believe that meets their needs. And one example that I wanted to bring to the discussion is the Impossible Burger, right? I mean, everybody knows this is, it includes a GMO, and yet everybody's eating it because it is more sustainable and meets that need.
That's a nice segue. I know Juliana wanted to get in a couple of questions on synthetic biology. And with the time marching on, we have 10 minutes left. Alex can take on some audience questions. Juliana.
Yeah, actually, I would like to jump. We have some great audience questions coming in. I'd like to just jump in with one of them from Louise, which asks, are there concerns about the impact of these engineered plants and trees on indigenous or native pollinators? And will these genetically modified species fit into the existing ecosystem?
I can perhaps talk a little bit about that. So for sure, the longevity of trees, where anything that goes into the field stays for decades, sometimes hundreds of years if used for sustainability conservation issues. The biocompatibility with the existing ecosystems, of course, a critical issue, and the biosafety thereof is something that we heavily looked into. And to date, with the tremendous body of work that has been produced, there has been no evidence that the biotech trees or plants in general have any real negative impact on the sustainability of the ecosystem. Of course, that is when the scientists follow the responsible research and innovation guidelines and are aware and do the work up front in a controlled greenhouse setting to ensure that whatever work that is done is compatible with the native species. And of course, there are, as Wendy and Chloe both mentioned, that is the unique advantage of the CRISPR approach, where a DNA-free modality allows the production of plants that are genetically indistinguishable from natural variants. So these are organisms, plants, and trees that can be found in nature. So that is how the USDA really defines the CRISPR technology that has been deregulated. So in that sense, as a natural selection process is used, it's similar to the CRISPR variants. We don't anticipate there to be any real surprises that will lead to significant detrimental effects when these are deployed.
Okay, thanks for that. And Jack, regarding what you were speaking about earlier with the species that are taking over and creating problems, we just recently covered in Gen the fact that gene drives were just developed in plants for, I think, the first time. Is that a technology that you think that we'll see being used to try to tackle this problem more and more?
Perhaps. So I from a scientific, technological, and biological perspective, gene drive is still a very early technology in development. So there's going to be quite a long way before it can be used in practical applications. And of course, there are only certain species and variants that gene drive can be operated on. Things that have a very rapid turnover time, that are using HDR instead of NHJ, and and also the occurrence of the resistant alleles. Those are all problems that need to be overcome before it can be deployed. So for sure, it's not going to be used in trees themselves, because imagine a organism that reproduces every 20, 30 years. Gene drive is not going to be very efficient. But to target invasive pests and pathogens, I can see that being a possibility down the road if it can be done in a safe and robust manner.
Okay, terrific. Kevin, I think I'll pass it back to you.
Yeah, Alex, did you have any audience questions you wanted to?
Oh yeah, there's been a bunch. One from Naoko to the group. What are potential issues in terms of licensing and intellectual property protection when using patented gene editing methods in plants?
Well, I can take that one. We, at Corteva, we had intellectual property rights from our, historical DuPont work, as well as entered into an agreement with Broad to license out that technology. We're not the only way to have access to that technology by any means, and I think there's constant evolution in this. But it is not, I would say, a constraint necessarily to get those license. And, we've been, in some cases, doing license for universities and philanthropic organizations without cost. So, part of this is really getting that technology out and not making the licensing piece a barrier, because I think the more innovation we have throughout the entire industry, in trees, in row crops, in fruits and vegetables, using this technology, the faster we're going to see the benefits globally of it.
And for Talon, I'd say it's a very straightforward. I mean, it's our proprietary technology, so very straightforward path from an IP perspective.
Okay. Great. And AJ wants to know, how close are we to commercializing CRISPR engineered food crops, and what are some of the specific crops where CRISPR has shown the most promise?
So I think,
CRISPR versus Talon.
Yeah, go ahead, Chloe, because you probably.
I mean, so Talon, there's already a product on the market, and actually the GABA tomato that was developed using CRISPR, I believe. So there is, and that is commercialized in Japan.
And traditionally, the crops that we're working with in Corteva are more not directly consumed by corn, soybean, usually are export crops going through for livestock feed, ethanol, et cetera, can be used in food directly. But I think one important thing just that, you know, as we see how this landscape evolves over the next several years, the regulatory piece is a really important element, both for enabling the technology, but enabling which crops and which opportunities we can use, because grain is traded around the world. And so it's not only if it's produced in the US or within Argentina that it's staying. And so having that freedom of this technology to go around the world is going to be very important in the applications that we're able to look at.
So in Trico, I have here in front of me the first ever CRISPR trees made paper. So we have developed a technology and a pipeline where we can generate unique variants of trees that can, when making paper or any fiber products, so you're looking at toilet paper, tissues, diapers, all sorts of things, they can be produced much more efficiently compared to the natural variants, release up to 30% less carbon dioxide into the atmosphere, and just more sustainable overall. So we are working with some of the largest, most sustainable and carbon neutral forest companies right now, trying to take those into market.
That's great, Jack. Congratulations. I want to get in a question from Georgina, who's been very patiently waiting. And it's a very practical question for Wendy and all of you, in fact. What's been the major regulatory hurdle you've had to deal with in terms of legislation on GMO in the United States and with international partners? Do you have any suggestions or advice for a small biopharma startup looking to get into confined field trials and later commercialization of GM plants?
Well, I think it's important to distinguish, are we talking about GMO or are we talking about gene editing? Because they're totally different things here. But, if we're talking about GMO, there's a pretty well set up set of regulatory, especially in the geographies that have modern regulatory systems. And so doing those trials is not easy. There's a lot of requirements for those field trials, but absolutely can be done. Somewhat simpler for the technology that we're talking about today. But Georgina, again, find me on LinkedIn. Happy to set up a chat to talk with you a little more about this.
And I'd say in the US, regulators are very open to just an informal early on consultation. So, check out their website, USDA website, and there is a way for a pre-submission consultation where regulators will walk you through kind of the requirements and how you could bring your product to market.
Yeah. Can we just quickly swing back to technology? We've talked about CRISPR, of course, and everyone's familiar with that, and Talon's being widely used at Calyx. What about base editing or maybe even prime editing? Is the editing technology itself still advancing and still being tested and experimented on by your R&D teams?
Absolutely. Both the enzymes and, the CRISPR enzymes themselves, as well as the applications. I mean, we can do simple things like just, delete certain base pairs or turn off certain genes. You can actually edit them and modify them. And all of these enzymes have differences in efficiency and also the crops that they're most efficient with. And so, yes, and we call this sort of enabling capability. There's a lot of innovation within our company and across the industry going on in this space.
I think in the CRISPR space, technology and methods and tools are no longer the limitation to the deployment of these technologies, but rather the delivery of CRISPR and the regeneration of edited plants thereof. Those are the key challenges, the domestication of this across different plant species, talking to different traits, that is one area of research that we think will really enhance the ability to generate variants moving forward.
Yeah. Well, we've had many questions. This has been a really fun conversation, a fascinating conversation. I wish we had another hour, but we don't, unfortunately. We're going to close the proceedings there, but I really hope we can have you back at some point, maybe later this year or early next year. So many more. This is such an important topic, and there's so many other avenues that I think we and the audience would love to pursue. So thank you so much to Wendy, Chloe, and Jack for your insights and a great conversation, and good luck to Corteva, Calyx, and of course Trico in the months and years ahead. Next month on GenLive, we'll turn our attention to the microbiome, so we hope you won't miss that. Wednesday, August 18th, 2 p.m. Eastern Time is the date. Until then, for the entire Gen team, Alex, Juliana, and John, in front of the camera, Danny Buda, and our production team behind the lens, I'm Kevin Davis. Thank you so much for watching. Goodbye for now.